Welcome to Log Review. We're going to review logarithms, exponential functions, and we're going to delve into interest. Now, the first thing you need to know is that for exponential functions, it is written in the form y equals abx. A is the constant, b is your base, and x is your exponent. We also have logarithmic functions, and it's written in the form log b a equals x. You guessed it correct. B is the base, a is the constant, and x is the exponent. It's very important to note that logarithms are the inverse of exponential functions. Exponential functions are the inverse of logarithmic functions. So how do we convert from a log to an exponent and an exponent to a log? It's very simple. If we have 3 raised to the power of 5 is equal to 243, then to convert that, we start with log. We write our base next to log. We do our constant, and we make that equal to our exponent. Another example. We start with log. We write our base next to log. We write our constant and our exponent. Similarly, if we have the log and we need to write it as an exponent, then we start with our base. We write our exponent and we make it equal to our constant. Final example. We start with our base, we write our exponent, and we make it equal to our constant. What else do you need to know? Well, we have a log, let's say, of 5. What is my base? Well, when there isn't any number written as a base, then our base will be 10. This is known as the common log. So we infer that our base is 10. Now, we can do our change of base formula. This is when we have our base in, we have one base and we need to convert that log into another base. What do? We log the constant divided by log the base. So for example, if I have log 4, 8, if I need to change a base, I can do log base 2, 8 over log base 2, 4, right? The other thing we need to know is that there are special properties of logarithm. And the first special property is log BB. What do you notice? Your base and your constant, they are the same. That will be equal to 1. So log 3 should be equal to 1. Log 4 equals 1. The other special property is log B1, that is equal to 0. So we have log 3, 1, that is 0. Log 4, 1, that is 0. Something else that we need to know is the inverse of a of an exponential function. So if we have y equals 2 raised to the power of x, the inverse of that is log the base x. Or if we have y 4 raised to the power of 3, the inverse is y equals log 4, 3. All right? No, just as exponents had different properties, log also has different properties. So for example, if we have log bm times n, we can expand that to get log bm plus log bn. Again, the reverse can be done. So if you have log bm plus log bn, you can simply multiply m by n. The next property is log bm divided by n. What do you think that will be? Log bm subtract log bn. Again, the reverse can happen here. And finally, if we have log b a raised to the power of b, then we take that power and place it in front of log. So we have p log b a. All right. What else do you need to know about log? Well, if we have this question, log 10 raised to the power of 7, what will we do? Well, we can take that power, place it in front of log. And we know this here equals 1. So if this thing equals 1, then it's 7 times 1, which will be equal to 7. Again, if we have 10 log 10, 2, this part here will be equal to 1. So it will be 2 times 1, which is equal to 2. What else do you need to know? Well, if we have a log, for example, if we have this thing here, 4 raised to the power of x minus 1 is equal to 5, and we need to solve for x. How will we go about doing that? Well, we're going to log each side. Then we're going to remove our power and place it in front of log. All right, then we get rid of log 4. So we have x minus 1 is equal to log 5 divided by log 4. And the final step is to add 1 to both sides. So x will be equal to whatever this gives us. Okay. Now, finally, we're going to briefly look at interest, and then in another video, we will do some more practice. So for exponential functions, we have learned that if we have a growth, we will use a 1 plus r raised to the power of t. A is our original amount, r is your rate as a decimal, and t is your time. We can also have a decay, and this is a 1 subtract r t. Again, rate is your, r is your rate, t is your time, a is your amount. A decay is when you decrease, growth is when you increase. Another term you may see is continuously compounding. And when you see that, you're going to use the formula A is equal to P E R T. And if we're dealing with interest, we will use A equals P times 1 plus R on N or T, plus or minus, if it's increase or depreciate or increase. And on the other hand is your time. If we see the term annually, then we will use 1. If we see the term semi-annually, we're going to use 2. If you see monthly, 12, weekly, 52, quarterly, 4. All right, so these are the basics for logarithms, exponential functions, interest. We will continue in another video.